Greetings and welcome to chemistry in the AM. But this works in the PM as well. We're just jotting down a problem, but I'm going to go through what we've already went through. I'll pause the video. So, recording, this is dilutions. And we understand dilutions intuitively. I talked about an example before I started recording where you have a concentration of 6 moles per liter and I double the water content, so I add more water. You know, it gets weaker. If you double it, went from 500 mils to 1,000 mils, you cut the concentration in half. 6 moles per liter, double the water, it becomes 3 moles per liter. Okay. What we're saying is when solutions are diluted or concentrated, we're going to stick to diluted. Concentrated, opposite. The amount of solute in the solution remains the same. So we could state that the amount of solute, the moles of solute before, equals the moles of solute after. And we know the concentration is the solute divided by the solvent. If the top stays the same, because the amount of solute in both situations, before and after, is the same. But we only change the solvent, the water. We should solve for the amount of solute. That's concentration times the amount of solute. Now, since the amount of solute is the same in the first situation and the second situation, we can say, well, the first situation, concentration, volume, first situation is equal to the concentration and volume in the second situation. That's where this comes from. It isn't which. Essentially, what you need to jot down from all this equation. C1, V1, C2, V2. If you need the words to explain it, pause the video. You're working through this example. So everyone has a copy down, so I'm going to go to a radial pen. And let's calculate the concentration of this. Well, hey, I need this formula. Calculate the concentration of a solution of hydrochloric acid created by diluting 500 mils of 6 molar solution with 300 mils of water. I've changed the amounts than what we did initially. So, let's read this carefully and think, okay, hydrochloric acid. We're looking for the second concentration. Calculate the concentration. So if you need thinking kind of things, I'm thinking, well, C2, that's what I'm wondering. Calculate the concentration. Created by diluting 500 mils. This is what you started with. This is my first one. This is my first concentration with 300 mils of water. I didn't give you the second volume directly. Let's think this through. I have 500 mils. I'm not putting the decimal in there. That's supposed to be ml. Pour in 300 mils. What's the second volume then? 800. Okay. Because I said I diluted 500 mils with 300. We're always going to be diluting. Not always adding. This is where I was saying I could do it one of two ways. I'm going to just say, what if I change the sentence to created by diluting 500 mils of a 6 molar solution with enough water to make 800 mils. I didn't tell you how much I added, but I just said enough water to make 100. No, it's actually, I gave you the answer, 800. With enough water to create 800 mils of water. So, read carefully what I'm trying to say. I'll do one or the other. Okay? So, I think we can see this, that the V2 Now, sometimes you'll need a calculator, but this one, 800 mils. Not yet, so we're just actually doing this. We're just doing this example. Okay. So, plug the information into the formula and calculate it for us. We have everything. We have. Hey, guess what? Your choice. Bad decimal. Let me just erase that. I hate the decimal, and then it doesn't matter the order you multiply things in, but I might as well keep 6.00 moles per liter of HCl. Volume initially is 500. I'm going to keep it in mils. If you want to change it to liters, you can. But I'll show you why you don't have to. Concentration is what I'm looking for. It's my variable. Solving for 800. Now I know the past, whenever you have mils, you change it to liters, right? And this works. Go ahead and change it to liters. But because you have mils on this side and mils on this side, as long as they're the same, you see that really they just divide out. So if they're matching, keep it in mils, it's less work. Really, what happens is when you divide by 800, this up. Okay. When I divide by 800 on both sides, actually I'll just show it. Why am I using this? This is how it's solved. I'm going to divide the whole side. I'm thinking of it more under. Really, what you're doing is you're just taking the ratio 500 to 800, 5 to 8. You're multiplying by the original. If you don't know what I'm talking about, just do the math for me. So this disappears. We're solving for C. That's the math, right? Just use a calculator. Top times top divided by bottom. Do that. Second concentration is 6 times 500 divided by 800. 6.75. Moles per liter. I want you, if you were given a chemical, obviously aqueous, you could add that, but I'll not be so negative on this. Get used to putting aqueous, solid, and gas, stuff like that. Now, that's basically as crazy as it gets. I have a few questions for you. Now, I'm not doing concentration ones, but if I was to concentrate a liquid, if I started with 500 mL of 6 molar solution, let's say a table salt, sodium chloride in water. Now, if I had that scenario and I said I want to concentrate it, concentrating means get stronger, right? How do I reduce the volume of something though? You can't subtract water because the salt, the sodium chloride, is mixed in it, right? I'd use some temperature change. You call it what when I reduce the volume of a pot of water? You do this at home sometimes. You don't do it for this reason. Well, you do with soup. What do? I don't think you do pressure at home too often. This is something you do most days. I do it. Boiling. If you boil something, you know it goes down in volume because the vapor releases. Now, if you do it with a solid like salt that's dissolved in there, you don't lose any of the salt particles, And you can boil until you get down to a certain volume, right? And that's how you can concentrate a solution. And it happens unintentionally too. You know that if I left a cup of water out here overnight, some of it evaporates slowly and it becomes a little stronger over time. That doesn't work with some things, though, that are dissolved gases, because when you boil it, the gas of the substance would also come up. An obvious one would be carbon dioxide, which also with pressure just starts releasing at room temperature anyway. But then if you heated it up, you're definitely not going to get a stronger solution because you're going to evaporate all the carbon dioxide as well as water change. So that works with some things. There's other techniques too that I don't know, but I'm sure there are. Okay, I'm going to give you your questions and I'm going to stop recording. But the math is the same when you reduce volume.